I'm going to do another example of a hypothesis test using a randomization distribution to find the p-value. In this situation, a research center claims that 25% of college graduates think a college degree is not worth the cost. A random sample of 200 college graduates were asked, do you think that a college degree is not worth the cost? 21% said yes. Is this strong evidence that the proportion of college graduates who think a college degree is not worth the cost is different from 25%? Okay, so first step is to set up our hypotheses. Is there strong evidence that? Okay, so this means that our alternative hypothesis is that the proportion of college graduates who think a college degree is not worth the cost is different from 25%. That's my alternative hypothesis. HA. I can see that it's about a proportion. So HA, the proportion P of college graduates who think a college degree is not worth the cost is different from 25%. It doesn't say more than 25% or less than 25%, so different from could be either way, so it's not equal to 0.25. And the fact that I have this unequal sign here in my alternative hypothesis tells me right away that I'm going to be doing a two-tailed test this time. My null hypothesis, on the other hand, is that P, the proportion of all U.S. college graduates who think a college degree is not worth the cost, is equal to 0.25. I'm going to test these hypotheses at a significance level. We'll use 10% this time. And the last thing I need before I start making my randomization distribution is I need a sample statistic that I'm going to use to estimate the parameter, P. Since P is the population proportion of all college graduates who think the degree is not worth the cost, I'm going to use my sample proportion as my estimate for that. My sample proportion has notation P hat, and it's 21% of my sample, so that's 0.21. Okay, let's go into StatKey. Now, once again in StatKey, I'm doing a randomization hypothesis test, so I know I'm going to be looking in this area. My hypotheses are about just one proportion, so I'm going to click here for test for single proportion. My original sample that's in here is 16 out of a sample size of 25. That is not reflecting my sample, so I need to edit the data. Now, I know that my sample size is 200, and that 21% of those 200 people said yes. So in order to figure out my count, I need to multiply 21% times 200. .21 times 200 gives me 42 people who said yes. So my count is 42. And now I can see that I have my correct sample size and my correct sample proportion. Now, the last thing I need to do is I need to change my null hypothesis before I start generating samples. My hypothesis, remember, null hypothesis is P equals 0.25. Here, we have P equals 0.5, so I need to click on that 0.5 and change it to 0.25. Okay, and now I can start generating randomization samples because I have my correct original sample that reflects my sample, and I have the correct null hypothesis that reflects my null hypothesis. So I'm going to generate 5,000 samples, 1,000, 2,000, 3,000, 4,000, 5,000. Now, as I said before, we had a not equal to sign in our alternative hypothesis, which means we are going to use a two-tailed test. Now, the two-tailed test is always going to show me 0.025 out in these tails. That's not what I want. I need to change this cutoff value to reflect my proportion. Now, my proportion is 0.210, so I'm going to enter 0.210 here. I did something screwy. Oh, okay. This happened because I entered 0.210 for the upper value in the upper tail. And if we take this out again, keep in mind that our 0.210 is actually down here in the lower tail. So when I do my two-tailed test, I need to put 0.21 in this lower tail. This makes a lot more sense, right? So if you see something crazy like that, probably what you did is you entered it into the wrong box. So if your observed proportion is less than the null hypothesis, then you want to put it in the box down here below. If it's greater than your null hypothesis, then you're going to want to put it up here above. Okay, so now what this is showing me is it's showing me the proportion of the dots that are at 0.210 or below is 0.111. And then I need to double that to get my p-value with a two-tailed test. I'm going to take my 0.111 plus my 0.111 in this upper tail, and that's going to be my p-value. My p-value is 2 times 0.111, gives us 0.222 for a p-value. Now the next step, of course, is to compare this p-value to my significance level. The p-value here is greater than my significance level. And since it is greater than my significance level, I fail to reject the null hypothesis. Which means that I do not have strong evidence that the proportion of college graduates who think a college degree is not worth the cost is different from 25%. And that's my conclusion. I hope this helps. Thanks.